Welcome to the Top of the Stack podcast by RisingStack, where we share stories on building great products with excellent engineers. The aim of the show is to discuss architectural design, development trends, and best practices for creating resilient applications. For our new listeners, RisingStack is a software development and consulting company based in Budapest. We are passionate about full-stack JavaScript with strong preferences for Node.js, microservices, and DevOps. To learn more about us, check out RisingStack.com for more content at blog.risingstack.com. You can also find us on Twitter and feel free to reach out for development advice.
So welcome everybody on this episode of Top of the Stack, where we are talking about software design and architecture of great companies. I'm Csaba Balog, your host, sitting with our co-host Tamás Kadlecik, CEO of RisingStack.
Hello, I'm Tamás, glad to be here today.
Today we are going to talk about the architecture of Pipedrive, a successful Estonian startup with locations in Tallinn, Lisbon, and in New York. Pipedrive is a sales CRM designed to help small sales teams manage complicated sales processes. The company was founded in 2010 and it's being used by over 50,000 customers around the world, such as Falcon Social, Mixcloud, and Discovery Channel, to mention a few. Our guest today is Kristo Kaiv, Head of Architecture at Pipedrive. Welcome, Kristo. We are glad you are here and you could make it today.
Hello. It's nice to be here, and thanks for asking me.
So let's dive into our conversation, Kristo. Could you tell us a bit more about your background and how you've become a part of Pipedrive?
So yeah, I guess I've been so far in my life pretty lucky. So I've been constantly going from successful startups to successful startups. So I was a long time in Skype, which is also one of the Estonian success stories. And I was there for 8 years and was mostly focusing on database development. So it was a crazy stack where even a lot of business code was running within the databases.
Mm-hmm.
And then I kind of felt a bit disconnected from the developer world, wanted to get my hands dirty, joined another small startup, but kind of in less than a year, I moved, and now I've been in Pipedrive for, I think, 3.5 years, or getting to be 3.5 years already. And started as a kind of normal developer because that was my intention in the first place. Didn't want to be a manager anymore. And yeah, look where it got me. So I'm pretty much back at where I started, but I think I'm smarter after all of this journey.
Mm-hmm. Can you tell us a bit more about the languages you use at Pipedrive to develop your platform?
So yeah, we don't have a really diversified stack. We do have PHP, which was the language that was originally used to develop the application. And after a while, Node.js was brought in. Where it kind of made most sense was using it for these kind of asynchronous scripts that need to do a lot of background processing and keep the processes open for longer. And it was, I think, approximately at the same time where RabbitMQ was brought into the stack. So all of these Node.js services, they were there mostly to complement the core PHP API functionality. And from front-end side, we were heavy users of Backbone, now becoming heavy users of React, and that's the way where we're kind of going, and trying out to go a little bit, but still a bit careful because it's kind of, we don't have too much expertise yet in Go, and also we are kind of relatively happy with Node.js, I would say.
What are the purposes you decided to use these languages?
I think it's for PHP. It's easy. It was the language that the founders felt most comfortable in, and I still think it's a great choice for what it does right now. And after PHP 7 got out, it kind of solved pretty much every single performance issue that we ever had. Well, not all of them, not the ones that we created, but I mean, we felt it's a bit sluggish, but it's working nicely now. But Node.js was for the places where you do need to keep an instance running for a long time, do a lot of parallel things. Like a good example is, let's say, socket server. You wouldn't want to try and write it in PHP. So I guess it kind of naturally got started. And I think people were relatively kind of cautious because the first code that was written with Node.js was the typical pyramid of doom. If you don't know what you're doing, then your Node code base can become pretty entangled. But I think right now it's the most loved language in our stack. We don't have Go yet, so can't comment on that. But it generally serves the purpose well, and there's some bits and pieces where it might be a bit tricky, maybe writing billing code, but for most of the things that you want as a SaaS app, it works nicely.
Are you evaluating Go as well right now?
Yes, we are. And why and where? It's usually the places where actually the milliseconds matter.
Mm-hmm.
So if you want to cut your response times down from, 6 to 3, then that's the place where we would be considering Go. Places where you have to manage a lot of memory. So if it's like the typical nodes up to like 2-4 gigs, I think we can run with it. But I'm not the big fan of how Node manages memory in regards of garbage collection. As soon as you need to have the developers manually tweak some things, then it kind of is not the best option. I'd just say so.
Yeah, that's definitely true. Can you tell us a little bit about what databases do you use?
Yeah, so in regards of these conventional databases, we use MySQL, and we use the Perconas, whatever flavor it's called. So we use both the Extra-DB and the normal conventional Percona server, I think it's called. Mm-hmm. But we are not using it in a common way in the regard that we actually do have a single database for every customer. And yeah, it's not like in MySQL, they would be proper real databases. They are more like, I would say, schemas if you compare them to Postgres. But they do their job of isolating the customer's kind of performance impact relatively well. So we are able to, like, because of this, it kind of enables us to do tons of really bizarre queries that you would never want to run on a table when you have, all of your customers' data together in one place, because you know that it will never use an index. So we use it kind of in a way that really fits our needs. But on the other side, it's kind of tough to manage because there's no good tooling for it. So a lot of it had to be created in-house, and it's far from perfect.
I see. And do you use it in a way that you have like one unified database that all your services use, or you have database instances per services?
So meaning where I started from, like where I mentioned MySQL as the first thing is that all of our core uses MySQL, and it has a database per customer. Mm-hmm. The new microservice databases that we are creating, for those we know that there won't be that much complexity. Like we can still kind of guess what the queries are going to look like, and what the performance impact is, what indexes they would need. And for those, we can use just normal MySQL databases. But the core of the customer data, I think, which is like huge amount of tables in hundreds, all of that is together, but it's not like a single database in that sense. It's the core as such is like one microservice. It's the huge monolithic microservice. And that one uses the MySQL like database per customer setup. The new ones, they usually use a new kind of storage mechanism. It's mostly MySQL. There's some bits and pieces in Couch.db, but we are trying to keep the set limited.
Thanks.
At RisingStack, we usually take testing our code very seriously and deploy only after running tests multiple times. So can you tell us a bit of how you handle testing at Pipedrive and what kind of tests do you have in place?
So testing, I would say we had originally, I guess, some UI tests. And when I joined 3.5 years ago, I think, there was not too much testing besides the UI tests done. But because we started growing relatively rapidly, there were more teams, manual testing was not an option. Then we invested quite heavily into establishing, first of all, unit tests, because you can't really do the microservices without having a lot of unit tests in place. Secondly, functional tests, usually like API. But when you go with the size that we have been doing, so we are right now, I think, 18 teams, then at some point you just need to rethink all of the UI tests. So there's some bits and pieces of the UI tests left. They are not actively written anymore because covering all of this code became relatively impossible. So instead of that, we try to do as many unit tests as we can, do basic integration testing, and each team is responsible for their own code quality. We've tried contract testing. It works, but it's so complicated that it doesn't get good traction. So I think it's still on the roadmap, and we're still trying to figure out how to make it work. But it's a difficult endeavor. Yeah, as for the environments, then of course, like unit tests run in your own machine. Then we have kind of these pre-staging test boxes where most of the services are run, but it's usually somewhat limited. So we try to fit it into one machine, and then the proper staging environment is lots of servers, and after that it goes to live. And to do all of that, then we've been investing mostly in the kind of glue code or the CI/CD tools wise. We are using bits and pieces from here and there. So we are using Jenkins heavily, but Jenkins is not the kind of main thing orchestrating everything. It's more to store what needs to be done and as a kind of run farm, let's say. Otherwise, yeah, CI/CD, GitHub, you do your pull request, it gets reviewed, it gets tested, it gets merged. I guess you know how it works.
Yeah, yeah, definitely. Just so the whole idea here is that our listeners get an idea about how successful startups run their whole production, from actually designing, then writing the code, then testing, and then actually maintaining it and supporting in production. So practically how it's done these days by successful startups. And regarding testing, I have two other questions. One of them is it can be quite problematic. Still, a lot of companies are really putting a lot of effort into trying to run the whole system locally on their local machines. Do you do that, or do you just run your unit tests locally, and then try out the features on staging or so?
I think it really depends on how your software looks like. And in our case, we do have this monolith that still lives in the middle. And because of that, I guess a lot of teams, when they write their microservices, there are not too many services that they depend upon. So it's not yet impossible to run them locally, but it's getting more and more difficult, especially as like one of the stacks, let's say, I don't know, mail probably is like 20 different containers already running. So at some point, we definitely need to rethink. Right now, at least one team can run all of their things locally.
I see.
I don't know where we are going with this, to be honest.
No,
It's a bit tricky.
no. In all honesty, I just asked you this because at a lot of companies, a DevOps team have problems with that. So like they have to kind of maintain the whole architecture and tooling for the whole architecture to make it possible to run locally. And usually the problem is that people start with a monolith that can be run easily locally, and they kind of hold on to this thought. And yeah, I'm usually just asking this so that to give them fodder and the argument. And yeah, you see, a lot of others don't try to replicate all the services locally, and maybe that's not the way to do. That's why I was asking, and I'm glad that you said that. Yeah, it's getting more and more complicated, and of course, when you have a monolith or pieces still of a bigger monolith, it's of course not that much of a big deal. But kind of when your architecture grows and you have more and more services, then practically what these kind of companies do is that they have one proper cloud provider when they have their production running, and then they have another cloud provider that's practically the crappiest, and that's their local notebooks, and that doesn't work. So that was the main question about, and thank you for the answer, because it really shows the way that actually I think personally that this should be done. So when it gets more and more complex, I don't think either that it makes a lot of sense to put a lot of effort into creating a local environment. And
I completely agree with you.
thank you. So the other question I had is when it comes to unit testing with microservices, with monolith, usually it's pretty clear where the unit is. So that's one object, one function, or something like that. But when you go microservices, the individual service gets smaller and smaller, right? So there are views that say that one unit is an actual service, so your unit tests should kind of resemble more to integration tests or end-to-end tests that you used before. So can you tell me your view on the unit when it comes to unit tests?
So I think it's more about like when we talk about end-to-end tests and what would you consider unity, I would say you really need to agree upon that beforehand. It's really hard to say.
Mm-hmm.
I don't think it's one service. I think it's the bounded context around it that you need to verify that it works together. But because it's really costly doing all of these tests, then much more needs to be invested into automatic like testing on the service level, meaning heavy unit test coverage, even up to 100% for critical core services in regards of branch coverage.
I see. Thank you. That you just said the bounded context. I think that's a very good way to put it. So yeah, thanks for that. I can use that later when I speak with others. Okay, let's move on a little bit from testing, but not so far away. So can you tell us a little bit about the CI/CD tools that you use?
So a lot of it has been built in-house by now, so I'm not the best person to talk about it because I haven't shipped any code to live for more than a year. And most of them have been popping up in the past year. But we still use Jenkins quite a bit. And we are not using that much of any of the SaaS tools right now. And I think we have most of the stuff settled, but we haven't even started to tackle the tackle the complex things like actual kind of dependency tracing or anything regarding that. So when you update the library, then you would want to actually run the tests that for the services using that library. So that's one of the things that we haven't really touched, and I think that's going to be the main kind of one of the main aspects when we consider the next set of tools. I think the things that we have right now are doing an amazing job, but at some point when we, I don't know, grow to 1,000 services or something, I think we need to rethink our strategies.
Can you tell us a bit more where your application is deployed? If you use PaaS, serverless, or container orchestration technologies?
We have something in the middle. We are using Rackspace, which is kind of a cloud, but limited. So you will get the benefits for, let's say, Terraform to automate things, but on the other side, it's going to cost you way less than running everything in Amazon.
I see. Well, that's actually a provider I've never really heard about. So, can you tell us a little bit more about it?
They are basically hosting a private cloud. It's built on OpenStack. And they don't have all of the fancy features as Amazon does, but it gets the job done. It's a OpenStack-based hosting provider, so that's the key takeaway.
I see. Okay. Okay, thanks.
Did you face any scaling problems in your current architecture? And if you did, like, how did you solve it?
We had some code that clearly could never scale, which is obvious. We rewrote it, but right now one of the things that we are completely revisiting is how we send messages. So we've been using RabbitMQ heavily, and at this moment we want to do some major shifts in how we handle brokers and messages. So one of the key things for our team to tackle this year is getting to 100% reliable events delivery. And we are using Kafka and some of the changed data capture tooling to attach them to the databases. And I think we might be able to get there. Let's hope so. We've done it once, I've done it once during Skype times. But why this is important to us is that we want to move more towards reactive architecture, so event-driven microservices. So we are not really going to take the approach that I think Uber and some others are pushing, which is making the calls between the microservices really, really fast. I think the approach that we plan to take right now is to have reliable event delivery, do a lot of materialization, caching, cache invalidation, event sourcing where it fits and makes sense, and rather move that way. And to enable that, we are right now looking into introducing Kafka, and in the future, that should take us to switching out RabbitMQ that we have been using so far.
Are you talking about caching in terms of asynchronous message delivery as well?
More like how the services share the data between each other. One of the ways is using the APIs and accessing the data fast and caching it on that side. The other patterns are event carried state transfer, event sourcing, where you take that data and you materialize it on the consuming services side. And you can consume it from there. You know, it's a bit stale, but it will eliminate the impact of constantly calling between services. It will hit the disk and, of course, create problems in a different place. But in the end, I think it will benefit performance of the application more than just doing these like constant API calls and optimizing if it's HTTP or gRPC.
Talking about gRPC, do you use it actually?
No.
No. Okay.
I think in one place, but we've been trying to not use it. Just keep everything HTTP because it's easier to debug. More tools. It's plain simple. You can. So yeah, that's the answer. We don't have that huge amount of API calls going on internally, so that's why we don't have it yet. But in general, the direction we want to take is having more materialized data and access that data locally.
One thing microservices are kind of marketed with, or a lot of people think of them that way, is when you go microservices, you have kind of graceful feature degradation out of the box. So, like, if there's a problem, the services fail separately. Whereas while we built our own tools and also while we worked for customers, we saw that that's quite often not the case, and that we needed to introduce tooling to actually contain these errors from cascading. Have you seen anything like that? And if yes, do you use any kind of tools at given places to contain the errors?
So I must confirm your suspicions. I don't think anything is automatically happening, and the issue is mostly that developers have gotten used to writing synchronous applications, and they don't think about it. There's so much tight coupling even in the microservice world, it constantly pops up. But in regards of like automatic failing, yes, we have thought about it. We have introduced this circuit breaker pattern in a couple of places, but I think there's no golden rule for this, and that's what makes it difficult. Sometimes you really need to put a lot of thought into how your service should be failing, and this is something completely new. If you write just one monolithic app, you never need to think about it. It works, or it doesn't work. So as long as people think about it and take the necessary actions, then I think it will work. No circuit breaker is going to save you unless you think in the right way. And that's the part that's hardest to change.
Yes, definitely. It's easy to say to design for failure, but a lot harder to actually do it and to write code for failure. That's definitely true. Can you tell us a little bit about what circuit breaker you use, if you use something, or if you wrote your own logic for that, and how did you put that in place?
I cannot answer you what the name of the library is. We picked out one from 4, and I can't remember the name of the library. But it was written in Node, and it was quite similar to the original. What was it called? Citrix?
Yeah, Citrix.
Yeah. So the implementation of it was quite similar. I think supported the statistics and stuff like that, but we are still in the progress of implementing. And we are going to introduce it in our kind of routing layer, probably first and fully. But we've been relatively busy with other stuff. So we just launched the multi-DC setup. So we are now hosting customers from both US and Frankfurt. And this has pretty much taken all of our attention away. So we will get back to that topic.
I see.
Can you tell us, Christo, how do you monitor your infrastructure? And what are the main metrics to monitor on your platform currently?
It is hard to say. We've been shifting a lot of it to the teams, and it works up to a certain bit. We still have operations, of course, monitoring things, and it's hard to put all of this into words, really. One of the key design decisions, though, is that we do think that the ownership of anything that is stateful should be in operations hands. So when developers write things, they usually write stateless apps that are run in Docker containers. So this way, there is better ownership and better expertise into monitoring the stateful things that are the main causes of issues. So let's say, I don't know, MySQL database operation knows exactly what type of plugins to use, what type of ratios to look for, let's say, queries made versus bin log or disk operations. So we try to keep that in one place, and operation uses their own metrics to validate it or provide the service quality. And on the other hand, developers are free to do whatever works for them. So it's a mixed pot.
I see. So when it comes to like the whole system, as I understand, you don't have unified metrics platform that you use kind of for everything, where you would, I don't know, propagate the metrics data to, but each team kind of has their own monitoring solution that they can use and set up themselves, right?
With metrics, yeah, it's a bit charted because people are interested in different metrics. As for logging and like we do have New Relic, but I wouldn't say that it fully counts as a metrics platform. It's like automated and it gives you a good enough insight, but it never really lets you define all of these custom metrics that you might be interested in. So in that regards, we do have things, but on the other side, we again don't. Maybe it's what I'm trying to say is it's not exactly what I think it should be yet.
I see. Okay.
Can you tell us, Christo, a bit more about the technologies you are very excited about in 2018, or what you are looking forward to implementing into your infrastructure at Pipedrive?
Mm-hmm. So as I mentioned, this Kafka thing is coming, and I'm not that much excited about Kafka, but it's more about event-driven patterns that we can hopefully use after introducing it. So that's the key thing for me to look forward to. And myself personally, I want to get my hands dirty on some of the neural networks and learning. I bought a new PC and I hopefully can run stuff within the 6 gigs of GPU RAM. So that's what I'm personally looking mostly forward to. But I think that's pretty much sums up what I'm excited about right now.
I see. Can you tell us a little bit about what you mean by event-driven patterns that you want to implement with Kafka?
One thing that if you really want to increase the performance and kind of the user experience of that is pre-rendering everything that you possibly can. And in order to do so, you actually need to know what the things are that are happening. And with Rabbit, we've been having quite a tough time because if you lose even one message in 100,000, the data is inconsistent. And you often need to write a lot of duplicate code just to deal with these kind of small gaps. So what we are kind of chasing right now is being able to deliver millions of messages without losing any, hopefully, if we get lucky. And if you have that type of like messaging quality, then you are able to leverage things like event sourcing or event carried state transfer to bring the data closer to the service that serves it, join it together with the service in the ways that you would like to do, and through that really kind of take a big part of the execution times for that service away. Because otherwise that service would need to go and validate everything via the APIs, pull the data together. And that is what makes the microservice architecture slowish. And you can't really fix these N+1 type of queries with just switching from HTTP to gRPC. Well, you can in some cases, but it's going to be tricky when you have a lot of data.
I see. So you're practically building on Kafka's at least one delivery nature and on the fact that you can always like look back on the event log and to like go back on the log stack.
Yes, that's the idea, basically.
Okay. So just for those who wouldn't know, Kafka works in a way that it keeps a log of all the messages, and then it's up to you to take the number of messages you need and Again, so you can always look back what happened before. Whereas when RabbitMQ, practically if a message is consumed and acknowledged, then it's a destructive operation. So that's why you can't look back in time if there's a problem.
Thank you very much, Christo, for sharing your insights with us today and the role what you play at Pipedrive. It was really great to hear how your infrastructure is built and the direction you are headed towards and what you're excited about in 2018. So thanks a lot again, and all the best with your upcoming endeavors.
I need it. Thanks a lot for meeting me. And yeah, I really need it.
Thank you for listening to this episode of Top of the Stack. If you would like to learn more about Node.js and architecture design, just hit blog.risingstack.com for more awesome resources. Stay tuned for our upcoming content. Thanks for listening. See you on the next episode.